We're now going to add all of those spaces on our unit circle that we don't have, so everything is equally spaced. So between 0 and 30 degrees, there is 15 degrees, which is exactly the same as pi over 12. So with our sum and difference formulas that we learned this morning, we can figure out the exact value of any pi over 12 family member, or anything that's a 15 degree or a 75 degree family member, without our calculator. So we're going to look at two examples first, two simple ones, cos of pi over 12 and sine of 75 degrees. So one in radians and one in degrees. Now the solution is we're going to think about values we already have on our pi plate. So we know pi over 3, we know pi over 4, and we know pi over 6. And beside them, I wrote them all with denominators of 12. Now if we add or subtract two of those values, then we'll be able to use our sum and difference formulas. So we have to look and say, could we use those values and get pi over 12 by adding or subtracting? Could you think of one way that you could add or subtract using two of those values and get pi over 12? Pi over 3 minus pi over 4. Can you see that? If you took 4 pi over 12 and minus 3 pi over 12, you would get 1 pi over 12. That's one way. Is there any other ways? Pi over 4 minus pi over 6. Because if you started with 3 pi over 12 and subtracted 2 pi over 12, you would get pi over 12. So we're going to find that there are different ways that you could get pi over 12 by adding and subtracting, and it doesn't matter which one you use to figure it out. So once you've figured out which family member you'd like to use, then we're going to write out the formula and then use our sum and difference equations or formulas to solve it completely. I say later on here, move this down, later on when we have bigger ones, you can use any pi over 3, pi over 4, or pi over 6 family to make it work. So what does this exactly look like? Okay, here's cos of pi over 12. If we choose the first one that we could say that cos of pi over 12 is equal to cos of 4 pi over 12 minus 3 pi over 12. Now if I simplified those, that's pi over 3 minus pi over 4. And I can make my pi over 3 my alpha and my pi over 4 my beta. I can then say, well, here I have cos alpha minus beta. Look on my formula sheet. What's my formula for cos alpha minus beta? It's cos alpha cos beta minus sine alpha sine beta. Put that in with your values, and we get an expression that has cos and sine, but now they're all values that we're used to on our pi plate. Because we know what cos of pi over 3 is. We know what cos of pi over 4 is. So we go to our unit circle. And the nice thing is this unit, you'll be able to use your unit circle on your test. So these questions become a lot easier. What is cos of pi over 3? That's a half. Cos of pi over 4, root 2 over 2. Sine of pi over 3, root 3 over 2. Sine of pi over 4, root 2 over 2. And then you have to write your final answer as a single fraction. Can you see that you have a common denominator of 4? So you can just add the tops, root 2 plus root 6, all over 4. So we just figured out what cos of pi over 12 was. Cos of pi over 12 is the square root of 2 plus square root of 6 all over 4. Without using our calculator. And we were able to do that by using our sum and difference formula. We first figured out two angles that we knew that added or subtracted to pi over 12, and then just applied the formula and solved it from there. So our part B was sine of 75 degrees. Well, now that you know pi over 12, you could figure out other ones by adding and subtracting with pi over 12. So your options keep going.
You could pick a few and figure out all of them.
Well, not all of them, because there's
But you could figure out all of
you
them.
could figure out a lot more angles, yes. Now, 75 degrees is 5 pi over 12. So the reason we call these pi over 12 questions is all the ones that we can now do, if you simplified them, there'll be something pi over 12. Since we're dealing in degrees, you've got 75 degrees, you have to think, is there a way on my unit circle to get 75? Well, one way is 45 plus 30. Can you think of any other ways? $60 plus 15, but we don't know 15 really well from our pie plate. It would work to use 60 plus 15 if you used 15 from before, but can you think of two ones that you know better from your pie plate? 120 minus 45. So if you took 120 and subtracted 45, you would get 75 as well. So I would like you to go from here, there's your alpha, there's your beta, and fill in the work and see what you get as your answer. I will show you in a second. Okay. So use your sine alpha plus beta formula. It has a plus sign in between. Get all those values from your pie plate, and it just so happens to be that it is the same answer as A. They're not always going to be root 6 plus root 2 over 4 for pi over 12 for sine and cos, but you will always find you have an over 4, you will always have a root 6, and you will always have a root 2. But sometimes there's going to be positive and negative signs that switch around. Okay?
On a test, we don't know if none of those numbers.
You will have those three numbers, but you need to show how you get those three numbers. Okay? The first ones I chose were really easy because it was really easy to see 30 plus 45 is 75. It was really easy to see 4 pi over 12 minus 3 pi over 12 is 1 pi over 12. What happens when you get pi over 12 ones that are bigger, like 17 pi over 12? So in our instructions earlier, it said you can use any pi over 3, pi over 4, and pi over 6 family member. And now you need them to add up to 17 pi over 12. So step 1, I want you to figure out what's going to go, what two things from your pie plate add up to 17 pi over 12. And we're going to make a list of them. Okay? So I need everybody to find, I'm going to tell you there's an infinite amount of right ways to add up to 17 pi over 12. And you each need to find a different one. So find one quick so that someone else doesn't find yours. Two things from your unit circle that add up to 17 pi over 12. All right, so the first thing we did, the frustration in these questions is the first thing you have to find out is two things that add or subtract to get 17 pi over 12. And as a class, we came up with these 5, and there's an infinite amount of them. But the frustrating part is, how do I find these? Is there a trick, or is there a way that I can find these easily? So let's look at the pattern of, let's look at the ones that we have and see if there's something in common in all of them. Root pi over 3 and pi over 4, but this one doesn't have pi over 3 and pi over 4. This one. Pi over 4 is in all of them. Okay? So I'm going to highlight that because that's going to be really important. Here's a pi over 4. 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 There's a pi over 4. The reason that's important, the pi over 4 is important, is because if you make a pi over 4 family member over 12, what is 3 pi over 4 over 12? It's a 9. And here we have a 3. And here we have a 3 again. Here we have a 21. And here we have a 9 again. What kind of numbers are those? They're odd numbers. And anytime you want to add two things and get an odd number, it'll always have to be one odd number plus one even number. So when figuring out 17 pi over 12, you always have to have a pi over 4 family member. What's a pi over 4 family member we haven't included yet? We have 3 pi over 4, 7 pi over 4, 5 pi over 4. So here is how you can find 17 pi over 12 is you pick a pi over 4 family member at random. They will all work. So I pick 5 pi over 4. What is 5 pi over 4 when you make it over 12? Times by 3. Can you see that that would be 15 pi over 12? I want to get 17 pi over 12. What do I have to add? Obviously, I have to add because it's not enough. I need to add 2 pi over 12 to make 17, right? So what does that mean this is going to be? Pi over 6. And it will always work out, no matter which pi over 4 family you choose, that when you figure out what you need to add to it, when you reduce it, it's something else on your pi plate. So 5 pi over 4 plus pi over 6 would be another one. I mean, you could be crazy. You could pick 101 pi over 4. Not recommended, but you could. 101 pi over 4 is the same as what over 12? Big number, right? Times by 3. 303 pi over 12. If you wanted to get 17, would you have to add or subtract? You'd have to subtract. You'd have to subtract how much? A lot. Take away 17 from 303. What would you get? 286? Okay. 286 pi over 12 reduces to 143 pi over 6. And it's part of the pi over 6 family. Now, not recommended, because you'd have to figure out, oh, what quadrant is that in? Don't choose too big of a numbers. But all of these other ones are pretty nice, because they're all on your pi plate. They're all on your unit circle. So one of the things, when we go back to our notes here, one of the things that I wrote at the beginning is that of your family members, pi over 3, pi over 4, and pi over 6, when you make them over 12, only pi over 4 is odd. And when you're adding two of them to get an odd number, that means you always need a pi over 4 family. It will not matter which one you choose. So when we're doing COSA 17 pi over 12, you could choose any one of them, right? But you always have to start with a pi over 4 family member. So I chose 21 pi over 12 minus 4 pi over 12. But no matter which one you use, your final answer will be the same. So usually I pick a random pi over 4 to start with, 21 pi over 12. Then I figure out what do I need to make it work. After I figure out what it needs to make it work, I simplify it so I can see what my alpha is. It's 7 pi over 4. I can see what my beta is. It's pi over 3. Plug them in because they're all on your pi plate. Now, in this question, unlike the first two that we did, some of these are in quadrants, like 7 pi over 4 is in quadrant 4. So cos will be positive, but sine will be negative. So this is where your positives and negatives can change. You have to think about what quadrants they're in. And when we simplify this, again, we get our root 2, we get our root 6, we get over 4, but now it's a minus sign in between. It used to be, there was probably a stretch of, I'm going to say 8 years where every provincial final exam had a pi over 12 question on it. The last 3 or 4 years it's been on and off. But it used to be you always have a pi over 12 question on your exam. And sometimes they would have a part B that would say, what is secant of 17 pi over 12? Well, if you know that cos of 17 pi over 12 was root 2 minus root 6 over 4, then secant is just the reciprocal, so you just take that fraction and flip it. I have another one for you to try right now. Everybody ready? You can do it on a scrap piece of paper if you'd like. You can grab some from up there. This was an old exam question, which added a little bit of a twist. See if you can deal with it. Here we go. 4 cos of 11 pi over 12. So what did I do? I picked a random pi over 4 family. I picked pi over 4. The very first thing is I wrote 3 pi over 12. And then I said, what would add to 3 pi over 12 to make 11? 8 pi over 12. And when I simplified that, sure enough, it's something else on my pi plate. The cos alpha plus beta formula has a minus sign in between. Figure out all your values from your pi plate. Be careful, because 2 pi over 3 is in quadrant 2, so cos is negative, but sine stays positive. Multiply it all out, you get your root 2, your root 6, and your 4. The minus signs are what is different this time. And so once you've figured out 11 pi over 12, then 4 times cos of 11 pi over 12 will just be 4 times this answer. Your 4's simplify, and you get negative root 2 minus root 6. Question number 7 has some more of these for practice.